Okay, so today we're just going to pick up where we left off, basically. I'll remind you where exactly that was, though, so don't worry. So we had just finished our discussion of this little example here, and it wasn't just a discussion, we also implemented it out fully. Oh, by the way, I do want to know, just so that I can tell where I can put them on the screen. Can you guys see the Zoom group chat currently open on my screen? Or only the... I don't know.
Only the inheritance things.
Okay, cool, awesome. So, yeah, we had just finished our discussion of this little example here. We had finished programming it as well, and we paid close attention to what these words abstract and sealed meant. Okay, so I am going to remind you about what all of these words meant. You know, very briefly. We won't go as in depth as we went last week, but hopefully you guys wouldn't need to anyway. All right, so here I've got the code open again. Ooh. And you guys can see my, can you see my cursor out of interest? Because if you can't, like, you can see what I'm highlighting, right? Hopefully. Okay.
Yes, sir.
Awesome. All right. So I'm just gonna say. Cool. So we had set up this little example where we had a base class called Polygon. All right. And from Polygon we had a derived class that inherited from Polygon. Okay, so hopefully you understand what I mean by all of those terms. Polygon defines a sort of abstract concept for a shape with multiple sides, and rectangle then inherits from polygon. Okay, and this is very similar to how a human would think about the problem, right? We've got a lot of different shapes. All of them have some common characteristics, but they're all sort of unique in their own way. And so what we're experimenting with is allowing a computer to understand that structure. All right. Cool, but we needed two extra words, we noticed, to distinguish between these two types of classes, right? I want classes that define abstract concepts, like a polygon, but I also want classes that define classes that define actual objects, okay, objects that I can actually instantiate, like rectangles. Okay, so we've got the abstract idea of all of these different shapes, okay, and then more concrete ideas about squares and rectangles. Okay, and don't get me wrong, it's somewhat arbitrary, the sort of structure we're setting up here, but you can hopefully appreciate why thinking about this way is quite powerful. Okay. And this is what the words abstract and sealed are used to define. All right. If we say that a class is abstract, then you are allowed to inherit from it, but you are not allowed to instantiate it directly. All right. So you would be allowed to inherit from it. So let me actually show you this in code. Might be a better way to see. All right. So we've got our polygon class here. Right? And you can see currently it's defined as abstract. Let me make this full screen so maybe you can see more clearly. Currently it's defined as abstract, right? So that means if I try to go polygon shape equals new polygon, okay, this would not be allowed, all right? Because it's abstract. I am not allowed to create an object of type polygon directly. All right, because it's abstract, I'm only allowed to inherit from it. Okay, I know we didn't really have any warm-up content today because we're starting basically in the middle of last week's lecture. So sorry about that, but once we work through this, we'll be able to start next week's lecture halfway through this one. Okay, so I'm not allowed to create a polygon object directly because it's abstract. Okay. I am allowed to inherit from polygons still, right? And you can see if I try to run this, that's what it would complain about. And it gives you a fairly self-explanatory error. It goes, cannot create an instance of the abstract class polygon, All right, and so you can see I'm trying to create an instance of polygon, but because it's abstract, that's not allowed. Right? If I made it not abstract, then it would be allowed. Okay, you see now it is allowed. Okay, so making it abstract just means you can't instantiate it directly. You can only inherit from it. All right, and sealed is also in some way related to this idea of distinguishing between abstract and concrete classes, if you like. Okay, so sealed, if I make polygon sealed, then I would no longer be allowed to inherit from it. Okay, you can only instantiate it directly if it's sealed. Okay, so obviously in our case we wouldn't make polygon sealed because we've defined it specifically to be inherited from, right? We've defined it as a base class. But hypothetically, if you want any class to not be inherited from, okay, then you can just call it sealed. Okay, and it is just as simple as putting the word sealed there. Okay, so you just need to know what that word means, and it's not too complicated. It means that now, because rectangle is sealed, in this case, and also square is sealed, I would not be allowed to create another class that inherits from either rectangle or square. Okay, cool. So that's what we ended off last week's lecture with. Hopefully you guys are feeling pretty comfortable about this idea of inheritance. In a way, some of you might... Okay, cool. In a way, some of you might even find it easier than the basic concepts of programming. Like, you know, the while loops and all of that stuff. Because in a way, inheritance and object-oriented programming is closer to how we think usually, right? It's closer to how we normally think, rather than how the computer phrases things, if you like. Okay, cool. So there was just really one more topic for us to touch on in this sort of space, or rather two, but the last one is very, very simple. Okay, so I'm just gonna talk about polymorphism because it's once you know the meaning of the word, it's not super complicated what this is referring to, all right? I think I did mention it briefly at the end of last week's lecture, but I'll pretend that we're starting again, all right? So polymorphism is Greek, so, or rather two Greek words, okay? Poly and morphism, all right? Poly is Greek for many, and we've already seen a use of poly today even with polygon, right? So there the meaning is taking on the same thing. Polygon, it means like many sides or something like that. In this case, it's polymorphisms. Poly still means many, and morphism means forms, okay? So, or form. So polymorphism is saying many forms, okay? So many forms. So what can this be referring to in our little case of inheritance here? Okay, so there's sort of just two more words that we need to learn about polymorphism, and any other sort of trick questions around it we'll cover when we get to the quiz at the end of this section. Again, doesn't count for marks or anything, just to, you know, cement our knowledge, all right? So polymorphism mainly refers to methods inside classes, okay? Methods inside classes. Is it online? What do you mean, is it online? The quiz. We'll go through it how we went through the quiz at the end of section 1 again. So if you remember how we did it at the end of section 1, I went through one quiz with you together, and then I gave you another just online one, so that you could try out some of the ideas yourself. Cool. Okay, so we've got this, we've got our class polygon. All right, I'm going to remind you what exactly it's defining. Okay, so polygon defines a length, all right, a length and a width. Okay, it doesn't say what they are, and it doesn't provide a constructor. All right, remember our class polygon is abstract, so we can't construct it directly anyway. So we wouldn't be creating objects directly from polygon. We could still define a constructor. In this case, we didn't. All right, so there's no constructor to actually set the length and width yet, but there is a length and width, a field for length and a field for width. and we decided together that they're both doubles, all right, which is numbers with decimals. We explored it a bit, we could have used any of the other data types that we're familiar with, right? As long as it holds a number, it can hold a length or a width, whatever. Okay, we also defined another method, or one method inside Polygon called area, all right? And we have noticed that both rectangle and square inherit area without trouble. Okay, both of them. I can show you that now. So here we define our rectangle rect object. Okay, and we give it a length of 10 and a width of 3. All right, you can see that's what the constructor for rectangles expects. It expects a double for length and a double for width. And then it goes ahead and sets the length and width. Okay. You notice that the field's length and width are not defined in rectangle, right? They're not defined in rectangle. They're inherited from Polygon over here. Okay, so they're inherited from Polygon, but rectangle can still define its own length and width. Okay. So you can see if I say console.writeLine rect, okay, rectangle, that's the name of our rectangle object defined over there. Okay, if I say rect.area, right, even though there's no area method defined in rectangle, it does inherit the area method from Polygon. Okay, and so in Polygon area, what does this method do? It goes ahead and it multiplies the length and the width together and just returns the number that it gets. And yeah, Bryn, you're exactly right. This will print out 30, assuming I don't forget to put the semicolon. Okay, or then it would just give an error. Okay, and we can do the same with square, right? So our square object, what is the name of my square object in my main method here? What do I need to do to call the area method on my square object? Okay, cool. And to call the area method on that object, what would I type? Ferrari.area, exactly. Okay, so I'll say Ferrari.area. Very strange name for a square, but that's okay. And what would we expect this to return? Right? It's a bit confusing in that, look, when we define a square object, we only give it one value. It's 8, hey? 8. But look, our area method says length times width. All right, length times width. So in square, we set length and width, but we set them both to this one value that we get. So this will give us so wrong square number. This in this case 8 times 8, 64. Okay, 64. All right. So in calling both of these, we should get 30 and then 64. So let's see that we do. Okay, so I go ahead and I run that. 30, 64. Okay, so this is working how we expect it to work. All right, it's working how we expect it to work. And yeah, the main thing we're paying attention to now is that the area method is defined here in Polygon, right? It's defined here in Polygon. It's not defined in either square or rectangle, but both of our square and rectangle objects. Maybe she saw a 6. I don't know. 6 times 6. Easy to get confused with all of these. What do they call these again? Squaring tables? What? I forgot. You guys practice these at school, right? I forgot what they're called. Whatever. So, yeah, so we've got our two objects here, right? We've times tables. Jeez, how did I forget that? Yeah, exactly. You have to practice your times tables. Okay, so cool. We've got our two objects here of type square and rectangle. Neither of the classes, as I've shown you by now a lot, right? Neither of the classes define an area method, but both our objects of rectangle and square have the area method because they inherit it. Okay, so hopefully we're comfortable with that idea. But like I said, maybe it's a bit confusing for us to be using the same area method. All right, it's not necessarily bad. All right, it's not the worst thing, but it is a little weird that when we calculate the area for our rectangle, we times these two different numbers together, and we also times those two different numbers together when we're calculating the area of our square. Okay, it's not the worst thing, but you can imagine if we had some other shapes, more complicated shapes, we would definitely want to redefine our area method, right? If we defined a new shape like a rhombus or whatever, there's going to be a different method for calculating the area, even though there's still a length and a width. Okay, so what I want us to explore is how can I have the same area method. I still want rectangle and square to have an area method, and it must still be called area, but I want to be able to redefine it in a few ways. Okay, so hopefully you guys understand that framing. It's not too complicated of an idea, right? So I want to force both methods to have the area method. I mean, both classes to have the area method, but they can have slightly different versions of that area method. Okay, and that's what we call polymorphism. All right, and think about it. It makes a lot of sense as a name. Okay, it makes a lot of sense as a name because the method area, okay, whichever method, will be taking on many different forms. Okay, it'll take on a certain form in polygon, all right? It'll take on a certain form in rectangle, and it'll take on a certain form in square. Okay, and I'm not necessarily guaranteed they're all the same, but they all will be called the same thing. Okay, so let's explore this idea. And there's two words that we need to know really specifically for polymorphism. Okay, one of them you've heard before, all right, and the other will be new to you. All right, so one of them, let's cover the new one first. Okay, is virtual. Okay, virtual. Right, so that's the first word. So what that means, I can make a method, all right, a method virtual. Okay, and how I would do that is I literally just type virtual here. Okay, virtual. All right. Now, what would this allow me to do? Okay, so we said we want to redefine the area method in square so that instead of length times width, it's just length times length. Okay, to really get the idea that this is the same number. All right. To really get across the idea that this is the same number. Again, you can picture more complicated examples where I want to define the area in a more complex way. But in this case, I just want it to be length times length instead of length times width. So you can see area here is length times width. What I want to do inside the square method is redefine area. Okay? And how I'll do that is I'll say, for now, I'm just going to put down exactly the same method. All right, I'm going to copy paste the method inside Polygon, and I'm just going to put it here. All right, it won't be virtual anymore though. Okay, so now you see I've got this exact clone of the method here. All right, I do want to show you what happens if we use this exactly. Okay, I'm just going to change this to length though. Okay, length times length. Right, so we're happy with that. I've just changed it to length times length inside our square class. All right, so you can see the area method is currently, we're trying to get it to take on a different form inside our square class. All right, this still works. All right, because it's virtual. Because it's virtual, it still works. Okay. I do want to show you, if I remove this. Okay, so area is no longer virtual. Okay, so it still works still. Okay, and this is it's a bit of a weird idea, but what I want to convey is that I don't know if I should explain it like. Okay, I'm going to introduce you to a new word. All right, override. override. So when I was doing this, okay, when I'm creating this method here, it's not changing the area method from class polygon. All right. When I define it like this, it's almost defining a new method. Okay. It's defining a totally new method. All right. I don't want it to do that. I want the area method to be the same area method that it was before. It must be like it has to have the same name, the exact same qualities. Okay? I don't want it to define a totally new method. I rather want it, think about it like this, to, in this class, to overwrite that method. I don't want to have access to that method anymore, if you understand. Okay. Again, it's a bit complicated because we haven't explored classes super in depth yet. But I want you to understand this word override. Okay. If I say override currently, you see it gives me an error. It says it cannot override polygon area because it is not marked virtual or abstract. Okay. Here, this polygon area, if I mark it as virtual, it allows me to override it. Yeah, in a way. I'm saying you have to have this representation. Okay, the old one isn't allowed. Okay, I will show you because I don't want to hide it from you, but it is a little bit complex. If I say something like this, like polygon Ferrari equals new square, right? This is actually okay, all right? Because all squares are polygons. Okay, so in a variable, my Ferrari variable is of type polygon, but I can save a square into it because squares are also of type polygon. They inherit from polygon, right? So there's a difference between me saying override the area method and just define a new area method. Okay. So it's a little bit of a strange idea, and you don't need to picture it in terms of what you know the word override to mean. Okay, you're overwriting the initial implementation of this. Okay, so it's a subtle difference, but again, don't dwell on it too much. The more important thing you must know is that virtual is allowing me to define an area method that works for rectangle, right? Notice, I haven't changed area for rectangle. Rectangle is still just inheriting the area method from polygon. Okay, rectangle is inheriting the area method from polygon. So you're saying it exists and doesn't, so it can be overridden. Well, if I override it for squares, then squares would no longer have access to polygon's version of area. Okay, let me explain it like this. That might be a good way of phrasing it. Okay, you've allowed me to think of that, Bryn. So look, there's a polygon, right? The area method is still just inheriting area from polygon. I mean, the rectangle class is still just inheriting area from polygon. We can agree on that. You see, when I run this, the area method for rectangle, when I say rect.area, it still prints out 30, right? So rectangle is still inheriting this area, okay? If I say override here, all right? If I say override here, squares will no longer have access to this area method, okay? They've now got this one, all right? If you don't override it, then it's almost like a gray area. Okay, it's like, which area method do you want me to use? Well, it depends on the variable type. Okay, exactly. Just think about that. So think about it that way. If there's an override there, it's just changing the old method. Okay, it's just changing the old version of the method for this class. It's not changing it for all the other classes. Rectangle's area is still the same. Okay, this is just overriding that original version of area for squares. Okay, not too bad. That's just what override means. Okay, so virtual is allowing me to define an area method here that other classes can inherit, and it's allowing me to override them when I want. It's allowing me to override the area method when I want. Okay. All right, so virtual allows me to define the body. We would call this the body, okay? There's some code here. Okay, this is the body of the area method. Because it's virtual, I'm allowed to define it inside Polygon, and I'm also allowed to override it in any derived classes. Okay? If I change this to instead be abstract, all right, then what's happening instead is that I can know, I'll run it so you can see the error. Okay, it says polygon area cannot declare a body because it is marked abstract. Okay, so if I instead mark my method as abstract, I am no longer allowed to define area here. Okay, so I can no longer provide an implementation or a body for area inside Polygon when it's marked abstract. Instead, I have to override that area method inside all of my derived classes. And so now any class derived from Polygon has to define their own version of the area method. Okay, so now rectangles have their own version and squares have their own version. Okay, and Polygon just says, by making area abstract here, all it says is that you have to have a method called area that returns a double. That's it. Okay, doesn't make any other requirements. No, so Tadi, the strange thing here, I suppose, is that you can see if I apply abstract to a class, okay, that means I'm not allowed to instantiate it directly. But if I apply abstract to a method, then I'm not allowed to define its body. Okay, so it's a subtle difference, but you have to think about when you're applying abstract to a class, it stops you from instantiating it. Okay, and then we can relate the word abstract to classes, but and sealed as well. But so keep that separate. Okay, so there's an abstract as it applies to classes. Okay, and there you can compare it to sealed. Yeah, exactly. So look, here I use abstract class polygon, and I say public abstract double area. Okay, so here's my method called area, and it's abstract. Okay, I also have a class polygon, and it's abstract. Okay, but they mean different things when applied to classes and methods. Okay. Yeah, exactly. So we can say here, this abstract you would compare to the word virtual or something like that. Okay, any class, class name. This abstract we would compare to sealed. Okay, it's a little bit confusing, but understand that they're describing two different things. Okay, abstract when applied to methods and properties is defining a is defining polymorphism, and abstract when applied to classes is defining inheritance. Do that, or sealed and virtual too. No. So just only think about abstract in that context. Okay. So it's just they use the word abstract to describe both. Okay, but you can think about it. It does sort of make sense. Okay, so the saying a method is abstract is saying like it's just a concept. You just want to define the general idea that all polygons have areas. Okay, you're not saying specifically how to calculate the area of a certain polygon, so you just mark it as abstract. You're just saying, I know that all of my polygons have an area and they're all doubles. Okay, that's all this method is saying. Okay, likewise for the class, it's saying polygons are an abstract idea. You're not allowed to concretely create any, you're not allowed to instantiate any specific examples of a polygon because they're an abstract concept. It's only here to be inherited from. And you can see that abstract things in both cases, like an abstract class, in order to actually use it, you have to inherit from it, right? You have to use it as a base class. Likewise, for an abstract method, you have to define it somewhere, right? And where it will be defined is in the methods, the classes that inherit from it. So you can see there is a relationship between the two words, definitely, between the two uses of the word abstract. In abstract, for the method, you just give it a definition, not the measurement. Yeah, exactly. Yeah, precisely. You're not giving it a specific way to calculate the area. You're just telling it that you have to calculate the area. If you're a polygon, you have to specify an area method. That's all this is saying. Okay, but that's it for polymorphism. All right. We can spend a bit more time on it if you guys have any more questions about it. But yeah, if you know what the words, so like virtual allows you to define a body and to override the method, all right? Abstract just sort of defines the method, okay? It doesn't actually provide an implementation, okay? It's providing an abstract idea of the method, if you like. Okay. Cool. I guess it's okay. Don't worry. We'll see more examples of this. In fact, specifically the next lecture focuses hugely on this concept of abstract. Okay, so if you don't understand abstract in this concept, in this sort of discussion, hopefully you'll understand abstract after we discuss this next idea. Okay, so abstract defines polymorphism and inheritance. Yeah, and it depends whether it's being applied to a class or a method. Okay, if we apply abstract to a class, then it's creating restrictions on our inheritance, right? It's saying that you have to inherit from this method. You cannot instantiate it directly. So here it's being used for inheritance, and here it's being used for polymorphism. Okay, same word, but based on what it describes, it takes on a slightly different meaning. Okay, but in both cases, you can picture it as if something is abstract, you have to inherit it. Okay, in order to use it, you have to inherit from it. Okay, so in both cases, it means that same thing, because you cannot use it while it is abstract. Okay, you cannot use it while it is abstract. You have to provide a concrete definition somewhere, right? So we have this abstract idea of a polygon, and we say, okay, but more concretely, a rectangle is an example of a polygon, and a square is an example of a polygon. Blocks abstract. What do you? It's they're interconnected in a way. Let me go through it again. Okay, so we've got this abstract class polygon. Okay, talking about the inheritance one first. All right. Yeah, exactly. So we've got this abstract class polygon. All right. So that's just defining the idea of a polygon. All right. Nothing concrete. And then we can say, okay, but rectangles, like rectangles more specifically, are polygons, right? So you're providing a concrete example. And here you go, look, squares are also polygons, right? Likewise, we can go abstract area, all right? There's an abstract concept of a method area that returns a double. And then inside rectangle, we say concretely, this is how you calculate the area of a rectangle. Yeah, actually it is. If you know the meanings of the words, they do make a lot of sense. And you can see it. There is a very English flow to it, in a way. Okay. Some things are a little bit strange, as we'll see in the next lecture, can get a little freaky. But in this case, I hope the idea of abstract is starting to make sense. But again, in our interfaces lecture, which is the lecture after next one, we'll deal with this concept of abstract much more closely. Okay. Cool, but that's polymorphism, and the main thing is, yeah, methods and properties can take on many different forms. Okay, and why do I say and properties there? Guys, remember getters and setters, you remember what those are? Those are methods, right? So they can also take on many different forms. Okay. Cool. So any method can take on many different forms. All right. And then likewise with other stuff. So, all right. Let's put polymorphism to bed for now. It is a little bit weird, and we will spend some more time on a similar idea. Are we going to be tested? No, and you'll be tested in a very abstract way, I can say, because remember, it's all multiple choice questions, right? So what can I really ask you about this? I can say, okay, if a class is abstract, what does that mean? And you must just be able to say, oh, well, then you're not allowed to instantiate it. Okay. If I say, if a class is sealed, what does that mean? It means, okay, I'm not allowed to inherit from it. Okay. You must really understand it on that level, understand what the words mean. Okay, what is inheritance? The ability of classes to inherit from other classes. In particular, they'll inherit properties and methods from those classes. Okay, that's the kind of idea you must understand. We do cover things more specifically because I do want you guys to actually know more about programming by the end of this. I don't just want you to pass the test. But obviously, hopefully in gaining that deeper understanding, the test will seem less and less intimidating. Okay. All right. Hopefully we're pretty happy with this. I think we got a few other people joining as well, but that's fine. I don't think I don't think the management has been checking the register much, to be honest. But we can see. Okay, and the last concept is encapsulation. And luckily you already know 2/3 of encapsulation. Okay, you know what public means. We're going to go over it again though, just in case someone's forgotten. Okay, but we know what public means, we know what private means, and you don't know what protected means, but you will by the end of the lecture. And this will bring us to the end of what was supposed to be last week's lecture. Okay, and then we'll take a quick break and go into the new slides. Okay, so let me just go over again the ideas that we've been thinking about lately. All right. So first we had inheritance, okay? And these guys, these 3 words, if someone asks you what are the 3 important components of an object-oriented programming language, you must know that there is inheritance, there is polymorphism, and there is encapsulation. Okay, so we've covered this concept of inheritance. A class can inherit from another class. We call these classes, like the person class and the polygon class, we would call those base classes because they're defining like a foundation, if you like. And we call classes that inherit from other classes derived classes. Derived, not deprived, but I can see that's probably obvious, just a typo. Okay, so cool. Inheritance, all right? Okay, and we learned a few words to do with inheritance, abstract and sealed, and we kind of got that, right? Like abstract means that you have to inherit, you can't instantiate directly. Sealed means that you're not allowed to inherit. Okay, pretty simple idea. Okay, we also spoke about polymorphism, all right? And we just briefly discussed this means that properties and methods can take on many different forms. And don't worry about that yet. We'll see a lot more of that in the future. All right, so we've got inheritance and polymorphism. Okay, the third important concept for an object-oriented programming language is encapsulation. All right, encapsulation. And what does encapsulation mean? It's like to enclose something. Okay, to actually, let's just see. I am not sure what encapsulate define. Let's see, what are some good synonyms? Okay, condense, capture, summarize, that's not bad. Enclose, this is more how C# is using it, okay? Enclose, encase, contain, all right, on public and private. Exactly. Yeah, exactly, it's protection, to enclose something, to wrap it up, to enfold it, to sheath it. Okay, exactly, so we already have some intuition about what encapsulate means. Specifically, there are 3 words that we need to know about from encapsulation. All right? There is technically one extra one in your book, I think on page 49 or something. I don't have mine with me right now, but we don't have to care about that one. I'll check the past papers for you. If it comes up, we'll just cover it quickly. The 3 important ones that you'll actually use are public, private, and protected. All right, we know what public means, okay, but let's explore this a bit more. Okay, I'm going to define another example. Okay, this is our inheritance example. I'm just going to go over to the 3 Ps. That's a good way of thinking about it. And that's another reason not to include the fourth one. So I'm just going to, can I go over to run code? Will it give me a fresh, yeah. Okay, so it gives me a fresh one. I'm going to define like a new example in order to explain encapsulation to us. Okay, the 3 Ps, Ps in a pod. Ah, good, good. Right, already coming up with a bunch of tricks to memorize it. Great stuff. All right, so let's see. Okay, let's start by just creating a super simple example about what public is. Okay, about what public and private is, to be more specific. Okay, so I'm going to go ahead and create a public class, and I'm just going to keep it simple. I'm going to say my class. Okay, we're also keeping it general, all right? Hopefully you guys don't need a concrete example of what you might define in a class anymore, right? You've seen lots of classes by now, and you can define anything you like. So we're just going to think about it in this general way for encapsulation. Okay, public class, my class. Okay, and for now, I'm just going to define a single field in my class. It's going to be public. I'm going to make it a string for now, and I'm just going to call it my field. All right, my field. Public string my field. All right, so if I go ahead and create an object of type my class, I could say my class, I'll call my object my obj, my object, and I'll say equals new my class. Okay, something like that. All right, actually this might be a bit annoying to type, so I'm just going to call it object. Oh wait, object is a reserved word. Okay, obj. Obj. We'll stick with obj. All right. So we've defined this object now. We've defined a super simple class with just one field called my field, and so we can see, like, currently, because my field is public, I can say obj my field. You can see it even auto completes for me. I can say obj my field equals whatever string I like, right? For now, we'll just say private classes restrict that. Yeah, exactly. So I'll say my string will be private classes restrict this. Okay, exactly. So I can put any string there currently, and you guys can see I can also access it, right? So I'm going to go console.writeLine, console.writeLine, and I'll say obj.myField. Okay, something like that. All right, so currently we know that this will run, all right, because it's public and it just works. It prints out private classes restrict this, and whatever I set the string to, it will set it to that. So I can set it to like dog or whatever, and it'll set it to dog. All right. A cleverer way to define this maybe is to create a constructor quickly. So let's just go ahead and do that. All right. I'm gonna define a constructor, so I'm going to say what's the rule about constructors, guys? They obviously have to be public because we need to be able to access them outside the class. But what else do we know about constructors? If I want to create a constructor for a class, what is same name as class? Exactly. All right, so it needs to say public my class. Now it's a constructor. Okay. In this case, I want to set one field. Right? When I construct my objects, I just want to set the my field field. Okay. So how many things does my object need to take in, and what type does the thing my constructor needs to take in? What type and how many variables? One, and it must be a string. Precisely. So I must say string. I'm just going to give it the exact same name as my field for now. Hopefully you remember how we get around this, right? Because how does it know which one is which? If we say this.myField, that means the one inside our class. And we can say this.myField equals my field. Okay, so now when I create an object of my class, I immediately specify the value of my field. Okay, And you can see this could still work. So initially I make it dog. If I make it cat instead, you can see that it'll update and it's going to print cat because it's public. Okay, so because it's public, I'm allowed to update it. I'm allowed to see it. Basically, anything you can do with the variable normally, I can do it from outside the class. All right. If I go ahead and make this private, now suddenly everything's going to break, right? Now it tells me this is not allowed. I'm not allowed to set it to cat, and I'm not allowed to read it. I'm not allowed to check out what the value is. Okay. Cool. So hopefully you guys know what these two words mean. Okay, we have public. If something is public, and this applies for methods, it applies for everything. If it's public, then it's accessible outside the class, all right? And if it's private, then it's not accessible outside the class. Okay. All right, how did we get around this idea of private? We can define getters and setters, all right? And we also saw that can be done automatically for us. If I say like my field and we always capitalize it, so now it's not, we're not going to call it my field anymore. It's now more like my property, okay? And it's got get and set. That's just the words they use. Don't worry about it. Like, so we can say a field is something without a, without getters and setters, okay? A property has getters and setters. It's just a nice way to distinguish between the two. But really, if you just call them all properties, you'll probably be fine. Okay. And now when I set it, we'll instead set it to, I'm just going to take in I'll just take in like a sentence instead and just set my property to that value. Right. So our constructor will still work. Sorry, I'm just framing the example in a little bit more of a realistic way. We'll go through it one more time after I've finished this. So my property equals sentence. Okay. Cool. So what I've done now is I've defined getters and setters, and C# just does that for me automatically. But guys, you know what get and set means, all right? Writing it in this new, slightly weird way, it's a little strange. You have seen it before, but like it may look a little bit weird. But don't worry about it, all right? You know what getters and setters are. You know why they exist. You know what this is doing. It's just defining a string that I can change, all right? This is just setting the string to an initial value. And now we can see, obviously I need to reference them with the correct names. So this will now be my property, obj.myProperty, and this will also be obj.myProperty. Ooh, but we have to remember capital M. Right, capital M. And now we can see the example works again. All right, but now my property, this string that we have is only accessible through our getters and setters, which allows us more control. And I want to show you how it allows us more control. Okay. All right, so actually maybe we can do this with a super simple field. It might get across the idea better. I don't know if I want to change it now. No, never mind. Okay. You guys are comfortable with what's with this code, right? I don't have to simplify it at all. Does anyone have any questions about any components of what's on the screen at the moment? Or are you guys comfortable with this idea of properties and stuff? Okay. I assume you guys are all happy. All right, fantastic. So we don't have to simplify anything. You're okay with the realistic example. All right, so we know what private means and we know what public means, all right? Public means it's accessible inside my class and anywhere else, all right? Private means that it's only accessible inside my class. But now, guys, what new concepts have we learned? So remember, we learned these two other words, right? We're currently covering encapsulation, but there were two other things that were important to object-oriented programming: inheritance and polymorphism. So we have this idea that I can access it inside the class and an idea that I can access it anywhere else, all right? But what new word could potentially change how some of our classes work, all right? We have this Yeah, exactly. We want to learn about this word protected. But what I want to get at is, why does this word exist? What if I say I'm going to change my class to instead be my base class? All right, my base class. I'm going to remove the constructor in my base class. All right, and I'm going to create another class. I'm going to call it public class my derived class. And I'm going to make it inherit from my base class. Okay. And I'm going to put the getters, the constructor here in my derived class. Obviously, I have to change its name so that everything works properly. Okay, and now I'm going to go ahead and create an object of type my derived class. Okay, so it's now an object of my derived class, and you can see that this still works, all right? Assuming I didn't make any programming errors or didn't leave out a semicolon, but I don't think I did. Yeah, it still works. Okay. Cool, so we have this idea of public, all right? Public means that it's accessible inside my base class, it's accessible inside my derived class, and it's accessible inside main, right? It's accessible everywhere, right? Inside program, I mean class program. So it's accessible in all my classes. That's what public means. If I make it private, then it's accessible in my base class and nowhere else. So what is the third option that I might want here, guys? So I have something that allows me to make it accessible everywhere, and I have something that makes it only accessible inside my base class. But what is the third option that I might want? Because you see, we've added a new thing here now, right? Like my derived class, if I make a property or whatever private, then exactly, but what would it mean? What would I use this third word for, right? So I have my base class. If I make something private, that would mean it's only accessible here, right? It's not accessible in derived class, and it wouldn't be accessible inside main if I made it private. Okay. But is the program class and derived class, should they both be excluded? Are they the same? Like, what's difference between my derived class and program? What's the difference between our program class, this class here, and my derived class? Why would I want to treat these differently? Well, let's think. Okay, so we've got program, all right? Program doesn't inherit from any of the classes we've created, all right? It's not inheriting from anything. Okay, we've also got my base class. It's not inheriting to anything either. Inheriting from anything either. My derived class is inheriting from my base class. Okay. If I make something private, okay, hopefully, maybe you're on the right track, we can see. So if I make like set, for example, if I make set private, then you can see that, I'll show you now. This breaks a lot of stuff. Okay, yeah. So what this breaks, you see it tells me something is breaking on line 28. Okay, something's breaking on line 28. So I go over to line 28. Because I made set private, my derived class is no longer allowed to set my property. This is broken. Now also main, the program class, it's also breaking on line 17, you see. So it's also breaking here. So now, because I made it set private, neither derived class or program are allowed to set my property. Right? You see that? If you're gonna, to what? Set up. Yeesh, that's bad. Huh. Well, hopefully you've figured it out now. Sorry about that. Okay. But let's, yeah, welcome. Before we take a break, guys, let's finish this idea. Okay, because you guys were on it. All right. So if I made set private, then you can see my derived class is not allowed to access it, and program is not allowed to access it. So we break in two different places. Okay, we break in our constructor for my derived class, and we break here. Now, I want you guys to see that and go, oh, okay, we've added this third possibility, right? What if I want something to be accessible inside my class, inside any class that inherits from me, but not anywhere else? Okay, we'll figure it out after the break. Just one second. Okay, so we've got... Okay, so appreciate that idea, guys. Because you'll continue with the next stuff, Dappe, because like we're right at the end of this, so I'm not sure. We're about to go on break, I think. Okay, guys, so there's this third option. What if I want it to be inside my base class? I want you to be able to access it. I don't want it to be private though, because I want my derived class to be able to access it as well. But I don't want program to be able to access it. Not quite, Bryn. The concept we're using here is encapsulation, all right? And the word we use instead of private is, I'll say, protected. Okay. Now, guys, notice, when it was private, I got two errors, all right? I wasn't allowed to set my property here, and I wasn't allowed to set it here. Okay. This time when I run it, all right, can see it loads. I only get one error. I'm not allowed to set my property here. Okay. On line 17. You can see it goes 17. All right. I'm not allowed to set my property here. Okay. So what is protected doing, guys? We have public, accessible anywhere. Private, only accessible inside your class. Protected means accessible inside your class or in any class that inherits from you, but not accessible in any class that doesn't inherit from you or isn't you. Okay, so it's only accessible in yourself and derived classes. That's what protected means. Okay. Yeah, well, in a way, in this case, Jones, that is actually correct. Yeah, the class program would not be allowed to access it or change it in this case. Okay, so cool. So protected, what it means is that it's accessible inside your own class and in any class that inherits from you. So in the main and derived class. No, in the base and derived class, Taddy. Base and derived class. Not, yeah, exactly. So I hope by main you mean the class that like is defining the protected thing. Yeah. But we would call that the base class. Okay, so it's accessible inside the base class and in any derived class. Yeah, any derived classes and itself. Precisely. Any derived classes and itself. Right? Okay. Cool, so that's protected, and that's the end of encapsulation. And those are the three important concepts of object-oriented programming, guys. Inheritance, polymorphism, and encapsulation. All right? Hopefully we have a good working understanding of all three of those things. Okay. I think let's take a break now because we have been going for an hour and about a minute. We can hopefully help Dat Bear sort out his troubles, and then we can start on with the next somewhat difficult lecture, but it should go fine, I reckon. Okay, let me go Control O. Awesome. Yeah, that's a great idea. I wish I had Oreos. All right, and when we get back, we'll start with this lecture. I'm going to have some water. Dat Bear, can I help you with anything, or like should I try stop sharing and share again and see if that fixes your problem? Cool. Okay, so I'm going to stop sharing my screen quick. And now I'm just going to share it again. Okay, I did it. Ooh, what is... Oh, okay, it's trying to say 10. All right. Okay, that's not bad. Nope, didn't work. See if you can send an empty message using tab. Huh. Okay, hold on. Okay, Dappe, I can try one more thing. So instead of sharing the specific window, I'll just share my entire desktop. Okay, did that work? No. All right. Yeah. Okay. Then I don't think it's trouble on my side because everyone else can see. So it must be your machine then. Are you using your laptop or something? Do you want to try? Perhaps you're using your phone or. Because I think maybe try the mobile app. That might work quite nicely if you have like a Wi-Fi connection. Ah, okay. Your phone is gone. Oof. Wow, we're in a bit of a catch-22 here then, huh? Yeah, I don't know. Sorry, dude. It's not... I don't think I can help you then. Must be that the PC is... Yeah, it's almost as old as me, actually. Not quite, actually. Ah, lovely. All right, so maybe it was just that your connection is a bit slow. Okay, but cool. We're on break, so come back at sorry, adapt there. Like as soon as you arrive, we're on break. So yeah, come back at like 3:10. And yeah, I'm just gonna go get some water. And then, oh yeah. Okay, I don't have to stand up anymore. I'm being brought tea, so that's quite nice. I see someone's discovered the whiteboard marker. That's good. You guys can use that, by the way. It's quite cool. You can also put your hand up in this thing, like you can raise your hand or whatever. Both of those are quite nice. 1 more hour until Minecraft Dungeons. Okay. Oh, wait, I should have sent you a thing. They did like an educational thing in Minecraft the other day. Oh, I forgot to send it. Sorry. Would have been quite fun. That's what it is. You can see it. Yeah, like some lecturer from... I think he was from Microsoft or something. And they had like a virtual classroom type setup. Seemed quite fun. I didn't join though, so can't vouch for it. Next time it happens, I'll make sure to send the link on the WhatsApp group. I forgot to this time. And this isn't actually the title of the lecture. It's this memory and events. So yeah, we'll probably get through memory, and then we'll call it there, and come back to do events next week. And events, guys, if you can make it through this set of slides here, this memory and events set of slides, then you will be golden. This stuff is quite difficult. I would say this is the most difficult section of the course. And yeah, if we make it through that, we'll start in about 3 minutes. Yeah, Minecraft it's also very well optimized and stuff. Like Minecraft, if your PC can't run Minecraft, then something's wrong. That's amazing though. Like Minecraft has been popular for so long. Hey? Like I was playing that game when I was there was a place called Zaps at Brightwater Commons, where they had like a bunch of computers set up so you could play multiplayer and stuff. This was before like online gaming was a huge thing. And yeah, like we were playing Minecraft all the time there. And then I was in like grade 6 or 7 or something. And people are still playing Minecraft. Yeesh. Oh yeah, that would be cool. Oh, I love tea. Sheesh. I think parents are more understanding about that kind of stuff now. Oh, they're not. Oof, sheesh. My parents were. Oh, come on, that's not... I mean, it depends what the thing is, maybe. But as long as it's not food, you're not being super mistreated or anything. That is quite a long time. Alright. Cool. We should get started again. Let's see if we can... let's see if we can get through this memory section, and then we can call it a day. Got some lunch here now as well. Yum. Ooh, that's hot. Huh. Yeesh. Okay. Cool. Let's get started. Right. Cool. So we know what set means, and we know encapsulation. So we'll have to remove that. Just run that. That works now. Okay. I'm going to just set up a fresh example quick, but the main thing really, let's go through the slides. Cool. Can everyone see? Is everyone back? Are you guys ready to start? Yeah, awesome. Okay. Cool. So, we're not going to be able to get through memory and events today. We're just going to cover memory, right? So what do I mean by that? I mean computer memory. Okay, so we're going to learn more in depth about what computer memory means, what it does, how the computer sees certain things, and it is quite an interesting concept, but please do concentrate, because if you lose your place, you won't be able to follow it. Dape, you're gonna have to watch the first hour of the lecture on YouTube, maybe when I post it afterwards, but this one, don't worry, you don't need any of the background knowledge from the last bit of the lecture. This bit is pretty self-contained, really. Okay, so first we need to do a quick reminder about what methods are. All right, before we go more in depth on our understanding of computer memory, we need to learn a bit more about methods, or rather revise a bit more about methods. Hopefully you remember this topic well. I would hope so. But if not, now's the chance to figure it out. Okay, so I've got a little bit of an example on the slide here. We will program it up and see how it works more closely. But let's just look at this first. Okay, so I've got my class program, super simple. We always have a class program, right? I've got my main method. That's the entry point for my code where the computer starts running things. Okay, we're comfortable with this idea as well. We say int x equals 3. Cool. By now, please know what this is doing. Okay, int x equals 3. Creating a new variable of type int. Its name is x. Its value is 3. Okay, happy with that. We then say console.writeLine. We know what this does. It just prints something to the screen, right? But then we say function x. Okay, so what's that doing? Well, we can see we've got two methods defined here, right? Main and function. All right. So when we call function x, all right, with these two little normal brackets there, the parentheses, the computer knows this is a method. Okay. Or C# knows that it's a method. So C# goes ahead and it finds function. Okay, and it just finds it from its name. Okay, so that name does have to be unique in the scope, all right, inside class program, so that it's able to find it. Okay, cool. And instantly, as soon as it finds function, what does it know about function? Okay, so it matches these up. It goes, okay, cool, I'm looking for a function method, and it matches it with that guy. Okay, what does it know about function? Well, it can see that it's an int. Okay, it returns an int. So picture it how the computer has to go through this. Okay, so console.writeLine has to know what type it's printing out. Okay, needs a place to save it so that it can print it out to the screen. So it needs to know a type. If you give it an actual number, obviously it'll instantly know its type. Okay, if you give it an actual string because of the quotation marks, it instantly knows its type. So it always knows what it's printing out. But if you say function x, how does it know what type it's printing out when it prints out function x? Well, there's a return type, right? So when function is finished running, the computer expects to be given an int. Okay, and it's that int that is going to be printed out. Okay, what else does the computer immediately know about function? Well, it can see here it says int a. Okay, it doesn't super care about the a yet, all right? It cares about int. Okay, so what is this telling the computer? Well, it says also, so, ooh, what's up? All right, so it has this int here, right? So what does the computer know? Do you do this on Tuesday now? Yeah, because the group sort of agreed that Tuesdays was better. Maybe we can do another poll or something in case it's not working for everybody. But concentrate. Or that we can discuss after the lecture. Okay, so function x, all right? So we've got, what does the computer instantly know? We've seen that it knows what it's printing out. It knows what function gives back to it, right? And it also knows what function expects. Okay, and that's how we would say it. So you can see inside the brackets here, function says int a. So what is it saying there? It's saying you need to give me an int. Okay, I'm going to call it a, but you must just give me an int. All right, so the computer has to check that. It goes, okay, we're giving it x. All right, is that okay? Int x. All right, yes it is. We're giving it an integer. Okay, so you understand that. As soon as it sees this name function, it goes and finds the method, and it instantly knows a lot about the function. It knows what the function needs, what you have to give it, and it knows what the function will produce, what it will give back, what it will return. Okay, so we give it our function x. Its value is 3. The function method goes ahead and it goes, all right, it saves 3, the number we give it, inside an integer called a. It says a times a. All right, we know the asterisk means times, so this is saying 3 times 3, that's 9, and then it just returns 9. So when we run this, we expect it to print out 9. Okay. And if I change the value of x, then it will print out something different. Cool. So that's just a revision of what the method is doing. And I want us to pay close attention to the words that we use to describe this quickly. Okay. So when we do this, when we say like function x, so a is x's value. No. Function x will return 9. Okay. Or a is x's value. Okay, let me think about what you mean by that. Inside a, whatever you give it, so whatever integer you give function, it will save its value in a. So if that's what you mean, yeah. A takes on x's value. Okay. We're going to be exploring in more detail how exactly that happens just now. But for now, yeah. So a will take on whatever value you give it. Okay. As long as it's an integer. So you could give it 3 here, 4, 5. You can change the value of x all you like. Or you can use another variable if you like. As long as it's an integer, a will just take on that value. Okay. But we'll see in more detail how that works. But the words that we use to describe this, when we type the name of a method and we put the parentheses there and we give it everything it's required, like we've done here, function parentheses x to give it x, what we call this is calling the method. You're calling the method. Okay? The things you give it, so like x here, we had called those parameters. Okay, parameters. It's called on x, you could say. It's called on x. But so we're calling the method function on x. The other way of saying that is we call the method function and we pass it x. We're passing it x. Okay, so you go, hey function, I'm going to pass you this number, x, this integer, and you just do whatever you do with it, and you're going to give back an integer, right? It's expecting you to return an integer. And whatever type you put there, the computer expects that method to return that. Likewise, whatever you put inside the parentheses here when you define the method, it expects you to give it that when you call it, right? You have to pass it those variables or those types when you, those parameters when you call it. Okay. Cool. So, I think let's actually program up this example, make sure it works, play around with it a little bit so we get the hang of it, and then we'll explore it in more detail. Okay, we have kind of done this before in a way, because we've seen this exact example before, in fact, but maybe we can play around with it a bit more and explore some ideas. Okay, if x equals 3, then a, but x is not equal. Okay, I don't really know what you mean by that question yet, but maybe we'll explore it when we see the example. Console.write9 a is not 3. What? So are you saying? So understand, a is only defined in function. Okay? A is only defined in function. Yeah, in a way, it's more about scope, we might call it, okay? X is defined in main, A is only defined in function. But we're going to explore this now in more detailed examples, okay? So I'm going to basically just define this exact structure here. So I'm just going to say static int, okay, it returns an int. We called it function. I guess we can call it that here as well. Function, define a body. Function, it takes in an integer, right? And we're going to call it a. Okay, we're going to call it a. And then I'll just say, how do we do it here? We return a times a immediately. Hopefully you guys are comfortable with writing it that way, doing it on one line. Okay, so we're returning a times a. The other way of writing this is to maybe create a new variable like int answer equals a times a, and then return answer. Okay, pretty similar. Okay, but hopefully you guys are comfortable with just returning a times a straight away. Okay, cool. And then in main, what did we do? We said int x equals 3. We could use any number we like, really. And then we just console.writeLine function x. Okay, like so. Cool. And so when I run this, we expect it to output 9, and it does. Okay. But let's play with this a bit more so that we can understand it a bit better. Cool. So here, obviously, if I change the value of x, I want you guys to really understand this example. So if I change the value of x to 4, what do I expect to be printed out? 0? How would we get 0? Four times 4. Okay, cool. I mean, if I gave it -1, what would happen then? If I gave it -1, exactly, it would return 1. If I gave it -2, it would return 4, right? If I gave it 0, what would happen if I gave it 0? I'm kind of using this as a question and answers time, and also using it as time to eat. Okay, exactly, it would return 0. Okay, cool. So hopefully we understand what this is doing. Okay, if instead of saying returning a times a, what if I return a? Okay, so if I just return a, if I make x 8, what will this return? Okay, so how does changing... Okay, cool. So now just... Exactly. This would just print 8. Okay. This would just print 8. Cool. And if I instead said a plus 2... Okay, I don't change the value of x. What would this print? A plus 2. What would this print out? It prints out 10. Okay. Cool. So is everyone comfortable with what this method is doing so far? It's a super simple method. We've seen it before pretty much. Yeah, so it's just changing an int in some way, maybe not changing an int. It does whatever you want it to do, right, to the int. You could equally, if I just said return 2, then now we can see that whatever I make the value of x has absolutely no bearing, right? This will always print out 2. Okay, cool. So hopefully we understand this example. You see now it said return 2, so it just prints out 2 always. Cool, so we can see how the value of x and a are related, and hopefully you guys can see I don't have to use x here, right? I can just type an int here directly, okay? And that'll work. Yeah, it'll work with anything. It'll work with anything. So I make a 12 here. If I say return a divided by 12, and I pass it x, okay, so x is currently 12, what would this print out? 1. Cool, so I mean, let's test that. See, it prints out 1. Okay, so it works. It always works. Okay, there's a little bit of niche things with integers, right? Because remember, they can't hold decimal places. Okay, so if I make x 3 and I make it return a divided by 2, what would happen there? Yeah, that's cool. Remember, I'm going to give you all this code anyway, hey? Creflo, so don't worry about it. It returns 1, yeah. Because currently we want it to print out 1.5, right? Because 3 divided by 2 is 1.5, but it doesn't know how to represent that 0.5. Okay. But anyway, that's a special niche thing. Let's just leave it as a times 2, or let's say a times a. Okay, so now it prints out 9. We're back to our initial example from the slides. Cool. So we can see it's passing function x, right? Its function expects one integer, it returns an integer, so we can understand this idea. Okay. What I want to see now, okay, guys, how would I make it so that this method returned nothing? What's the main thing I would have to change to say this function returns nothing? Function doesn't return anything. What would be the main change? Currently we've got static int function. In that little declaration there, what would I have to change? And what would I have to change it to? Static int function would have to become static what function? Static void. Good job, good job. Okay, so we're going to say void. Do you guys remember what that means? Okay, that means you cannot return stuff. Okay, you cannot return anything. Okay, that's what void means. So what I want to do now is just print out, instead of console.writeLine function x, we're just going to call function x, right? It doesn't make sense to print out function x anymore, right? Like this. Because this now doesn't return anything. Okay, so if you see it doesn't return anything, it returns void. So when I try to print it out, cannot return, oh right, let me just return nothing, sorry, like that. I think it'll break anyway, yeah. So you can see I can't print it out because it's not returning anything. It's like, how do you print out nothing? Okay, so now we just call function x. Okay, we just call function x. Like so. So now how do I go, I'll print out a now directly, okay? Or a times a. So all I've changed is I'm no longer printing out function x here. I'm just printing out inside the function, okay? Because I'm not returning anything anymore. Do you guys follow? So now it's just doing the same thing. This will print out 9, but it's no longer returning 9. It's just printing it out immediately. Do you guys understand that little change? It's nothing too major, right? This just makes it easier to explore this example we have. Okay. Cool. But what I want to do is explore this idea a little bit more. Okay, so I'm going to go back to our slides quickly and set up a little sort of illustrated example. Okay, so cool, that's all done. Okay, cool. So there's two important, there's always two, right? There's often two rather. But there's two important ideas that we need to know, okay, to really understand how the computer sees this passing of our variable x to function. Okay, we call function, we pass it x. How does the computer actually do that? Okay, and there's two possible ways it can do it. All right, the way we've been looking at is called pass by value. And the other weird way is pass by reference, okay? We're going to ignore pass by reference for now, and we're going to focus on pass by value, okay? And really explore what this means. Should speed up a little bit because it's already been sort of 30 minutes. Okay, cool. So we've got pass by value. And you can see in brackets there I just put copy because that's basically what it's doing. Okay, but in order to represent this in more detail, maybe you remember I did this before with that while loop example where we had the computer's memory sort of represented in the bottom left. Okay, and I've done that again. I've set up a little memory representation of the computer's memory. Obviously, that's extremely oversimplified. It's much more complicated than that. But the idea is, you know, you've got your address 0, number 0, address 0. It's pointing at maybe your browser or your whatever, Word, something like that, Zoom maybe. Okay, it's pointing at something. We've got a whole bunch of address spaces. Okay, address space 1 pointing at main. Okay, obviously this is way more complicated in your actual computer. There's a bunch of address spaces. We only care about address space 2 and 3. Okay, for thinking about our problem. Okay, and these little black dots here, they mean that that address space is currently empty. Okay, that's what I'm just using to represent that. All right, currently. Cool. So we've got a representation of memory in the bottom right there. And I'm just going to run through, there's only 2 lines in main. I'm going to run through what each line does. Okay. So first we go int number equals 6. Okay, you can see on the right here, that's the line of code I'm running currently. Int number equals 6. Okay, so what will that do? it goes and frees up, you know, some open place in memory that's large enough to hold an int. And it goes, okay, I'm going to create, I'm going to set this memory address, all right, to 6, okay? The value at this memory address is 6, and I'm using the word number to refer to that memory address, okay? So when you say number, I'll just go to that memory address and fetch 6, okay? And whatever value you gave it there, I would just go and fetch that value, okay? We're okay with that. Cool. And on the next line of our code, obviously we just called this X in our code. Same principle though. All right. Maybe we can change it to be more in line with the slides when we go back. Okay. On the next line, we call function number. Okay. So we call the method function and we give it number. All right. So what is that doing? What this actually does, you don't necessarily see it. At least you won't see it unless you know that it's happening. But what this actually does is it goes and frees up another space in memory, also capable of holding an int. It makes a copy of it, and it saves 6 there. Okay. And this address space 3, okay, the copy, is what we actually give to function. Okay. We don't give function number, we give it copy. Okay, we give it the copy. Cool. So what does that actually mean? We can go back to our little example that we were programming up, and I'll show you what I actually mean by this. Okay. But the main thing is that we call this pass by value. Okay, so it's passing the value 6. It's not passing the actual variable number, or X in our case. Okay. So let's go ahead and see what this actually means. All right, so I'm going to make the code full screen so that we can see more clearly. Okay, so we've got our variable function here. In the slides, I didn't call it int x. I called it int number equals 6, okay? And then we called function number. Okay, that's what you saw in the slides. All right. Here is our definition for function. We didn't see this in the slides, but it doesn't really matter. Okay. Cool. What we're going to do is see exactly how changing a inside function, whether or not that would affect main. Cool. And I want you to see, I want to get your intuition on this after you have seen the slides, okay? Understanding that we're passing a copy, I want to get your intuition on this. Okay. So what I'm going to do is I'm going to say a equals a plus 2. Okay, and then I'm going to print out a. Okay. So currently, can you guys tell me what will this print out? So I say int number equals 6. I go function, I pass it number. Function goes ahead and saves it in a. I say a equals a plus 2, and then I print out a. So what does this print out? Okay, Taddy says 8, Young Millionaire says 8, Creflo says 8. That seems like a pretty good answer, right? 6 plus 2. Yeah, I agree. This will print out 8. Shall we run it just to make sure? Does anyone disagree? When I run this, we can see it prints out 8. Okay, see it prints out 8. Happy with that? It makes sense, right? That's what we would expect. Okay. 8, 7. Okay, cool, so it prints out 8. Okay. If you guys were worried about that little 9 that was there, that was from the last example we had run, right? Okay. Cool, so this prints out 8, and that makes sense. That's what we expect. Okay, we're just adding 2 to it. That's once you understand what's going on here, this is like super trivial, right? But now, what if, so I call function number, right? We know this prints out 8. Okay, yeah, don't, that was from the previous example. It saves what it has previously printed, right? Okay. Now this is interesting, guys. I want to hear your intuition on this. If I print out number here, okay, this will now print out 2 things, right? Because it comes here and it prints out whatever the value of a is. And here it prints out number. So bearing in mind what we said on the slides, what will this print out? Okay, it'll go to function and print out, we know it prints out 8 inside function, but it'll print out 2 numbers, Taddy. We know calling function number prints out 8, right? Where would you get the 4? Or did you mean 6 and 8? Okay. IDK. Okay. 6 and 2. Ooh, 6 and 2. All right. I want to see your guys' logic here. Okay, 6 and 8. 6 and 8 is a good answer. All right. In fact, that's right. Okay. But let's go through it line by line and see what the computer is doing. Bearing in mind that when it passes a thing to function, it makes a copy. All right. So what will happen here? It'll go int number equals 6. We know what that does. It's creating number, all right, making it 6. But guys, remember not to trick yourself with things like this. It's not that tricky. Okay. We go function number. All right. So what this is doing, it makes a copy of number, and it calls it a. All right. And then it goes into function. What does function do? It says a equals a plus 2, so it's adding 2 to the copy, a, and then it prints out a. All right? That gives us 8. All right? So if the first number this will print out is 8. Okay, when we call function number, that prints out 8. Then when I go console.writeLine number, it will print out 6 still. Okay. So this will print out 8, 6. Okay. I'll run that just to show you. Okay, run. Do. 8, 6. You guys see that? So, what idea did I want you to see here? Okay. Let's go through that. Notice, in function, we change a, right? We add 2 to a. What I want you guys to see is that that does change our variable a, right? Inside function, a has a value of 8 by the end of it. But when we actually print out number, the variable we passed to function, its value did not change. Okay. Its value did. I mean, it is different, right? It is different. But yeah, in a way, you can link the ideas in your head. You could, but make sure it doesn't make you confused. This is what we call passing by value. All right. You can also think of it as just making a copy. Okay. So if I make number 10, what will this print out? It'll go into function number. It'll add 2 to 10, and it'll print out 12 exactly. And then when it comes back, it'll print out 10. All right. So this prints out 12, 10. Okay. But you see, number is not changed. Right? Number is not changed. Okay. In this case. All right. So this is what we call pass by value. All right. Now, maybe you can see there is another way to do this, right? Currently, I make a copy of number and I pass that to function. Hypothetically, I could actually just pass number to function, right? That should be allowed. How would I do that? Okay, you guys don't know how you would do it yet, but you can see that there is another way we could do this, right? So we make a copy and change it. Yeah, we change its name from number to a. But remember, number still exists, okay? It's just that a, right? It's exactly like this, guys. Exactly like this, right? Number still exists in memory, right? In address space 2 in our silly little example here, right? Number still exists in memory, okay? But it's just that function doesn't work on number directly, okay? We give function copy. It works on copy, and number just stays itself up in main. It's a fairly logical way of doing things. You know, you don't expect it to change the original, right? You keep the original and you just give it a copy, all right? And that's what we call passing by value. But there is another way to do this, There is another way to do this, and that's called pass by reference. Okay, and you'll see where we'll set up the exact same example, and you'll see that there's a very clear difference between these two things. Okay, hopefully you understand pass by value. It's working on a copy, right? Simple idea, and we can see it with other variable types as well. Maybe I should show you that before we go on to the next thing. Let's see it with a string. Okay, so we make a copy and change it from that. Okay, let's see with a string. So instead of an int, I'm going to say string. Instead of number, we'll call it name. All right, doesn't really make a difference. Actually, I'm going to leave it. No. Okay, I'll call it name. Fair enough. And for now, who's the last person who sent a message? Creflo. Okay. Cool. We're now going to pass function name, right? And I'm going to console.writeLine name at the end of this. And it's still going to take in a, but it's going to be a string this time, obviously. We can't just add 2 to a string. So instead, I'm just going to change Creflo to the previous person was a Bryn. Okay, let's change it to Bryn. And cool. So what will happen here? What do we expect to happen? It's going to print out function name will print out Bryn, right? And this will print out Creflo. See, it prints out Bryn, Creflo. Okay, so this works with all data types, right? All of them. Okay, all of our like normal data types, the ones that we've been working with, right? Like doubles, floats, all of these guys, they're all passed by value by default. Okay, so we make a copy of them and then we pass the copy to the function, all right? But like I've been mentioning, there is another way to do this. So let's see that. Okay, so I'm moving back to the number example. So this is printing out 1210 currently. Okay. So I see you guys hopefully appreciate that. Okay, so pass by value. We're good on this. What about pass by reference? Okay, pass by reference. There's another way to do this. Okay. So setting up the exact same example, but this time we're going to pass by reference. Okay. Instead, and we'll see how you pass by reference. Obviously, you have to tell the computer. It's not just going to like trick you. You have to be clear that you want to pass by reference or pass by value. And there's certain rules around this, okay? And those are what we're learning. Okay, so same as last time, I'm going to create int number equals 6, and the computer does the exact same thing. Okay, it goes to memory, the next open memory address, okay, number 2, and just saves 6 there. Cool, happy with that still? But now, instead of passing number to function, I'm going to pass ref number. Okay, ref, hopefully I don't have to tell you what that stands for, but I will anyway. It stands for reference. Okay, we're passing by reference. So I say reference number. Okay, what happens this time? You remember last time when I passed number directly, we went to address space 3 and we saved a copy of number there. But now because I say ref number, it will no longer do that. Now, it just gives it address space 2. Exactly, it gives it number. Okay. So, we have to go back to our example again and see exactly what this means for us. But hopefully you can already see how this is going to change things. I'm no longer making a copy. Right now, when I change it, it's going to change. So, let's go back to our example and change it in this way. Right? It's a very easy change to do. Okay, so we create int number equals 10. And I now, instead of passing number, I'm going to pass ref. And you can see ref is highlighted in purple like that. You can see all the other like public and class and namespace, they're all highlighted in purple. That means C# recognizes the word, right? It recognizes ref. It knows what ref means. It knows what reference means. Okay. But now it's taking in ref number. It's no longer taking in int a. It's taking a reference to an integer. Okay, so I have to tell it there too. So I just have to tell it in 2 places. You know, I have to tell function that it's now expecting a reference to an integer, and I have to give it a reference to an integer. Okay, simple change. But seeing what we just saw on the next slide, okay, what will this print out this time? Before we even see it, we go int number equals 10. We say function, we say reference number. So we're no longer making a copy. We go into function, we say a equals a plus 2. So, we're adding 2. We print out a. Okay, that's still going to give us 12, right? But when we go back to main and print out number, what do you guys think? Is that going to print out 10 or is it going to print out 12? What do you guys think? You still think it's going to print out 10? Both. Yoish. Don't trick yourself, guys. Remember, it's still only one. It's still only it's just an integer. Number is just an integer, right? And we're just no longer making a copy of it. Okay. We're just no longer making a copy. So you'll see when I run this, previously it printed out 1210. When I run it now, we're passing the reference instead. You can see it prints out 1212. Okay, 1212. No, guys, remember, it keeps the previous thing it printed. Okay, I hadn't run it yet. Okay, but you can see it prints out 1212. Okay, so what's happening? This is now no longer making a copy. Any changes that I make in function, okay, if I add 6 here, this is going to print out 16, 16. Any changes that I make in function are now reflected in main. Okay. So it's quite an interesting idea, right? It can either pass a copy of the value or it can pass the actual memory address. Here it's passing the actual address in memory. So function knows what, like when main references number, like the place in memory that number refers to, right? Like number is referring to a specific part of memory. When main refers to that, because I passed a reference, function is now referring to the same place when it says a. Okay. So hopefully seeing this idea, you gain like a new appreciation for what variables are representing, right? It's like an actual place in memory. Okay, and I can refer to that place in memory or just like a copy. Okay. Cool. So I'm going to go back to the initial example. So this will now print out 1610. Okay. So I'm no longer passing a reference. We've gone back to passing by value. Okay. So in this sort of primitive example, do you guys have any sort of questions about the difference between pass by value and pass by reference? Or can I go on to like our last little bit of this concept? Any questions about it? Everyone's comfortable. Pass by value, we make a copy of the variable and we give that to function. We pass that to function. Pass by reference, we don't make a copy and we give function the actual memory address. Okay. Quite interesting though, how specific you have to be, right? And how specific what the computer is doing. And you can see that could change a lot about how you work when programming, right? Like knowing that it's not working on the original thing or that it is working on the original thing. Okay, cool. So we've got these ideas of pass by value and pass by reference. Okay, and hopefully we're comfortable with them. However, there are a few things to note, as always. Okay, so yeah, let's just go through. It's just a short list, really. So first thing to note, all objects in C# are passed by reference. Okay, all of them. So what do I mean by that? Well, let's go see. Okay, so I'm gonna create by default, but always, like there's no getting around it. We can go into why this is. We only have 8 minutes. Maybe we have to go a little bit over time, so sorry for those of you who are rushing to get to your Minecraft dungeons, but I'll try to be quick. Okay, so I'm going to create public class rectangle. All right. Yeah, you can see people are already suspicious. Okay, I'll call it my class. Let's be super quick about this. Public class my class. I'm going to say public string name. Okay, so it's a very simple class. Okay, it just has one field. Hopefully you guys are comfortable with creating a class like that. Okay, I'm going to create an object of that class. So instead of creating number, right, let me just comment these out. Oh, that doesn't work in thingy. Okay, I'm just commenting out all these lines here. Okay, and what I'm going to do is create an object of type myClass. Okay, myClass obj equals new myClass. All right, like so. Shame. Okay, cool. So I've created a class. All right, obj.name equals dappe. All right. Okay, we're setting name to dappe. Cool. I'm going to use this exact same function, all right? Except now, function is going to take in something. This might scare you guys, but don't worry, we'll look at it more next week, okay? Function is going to take in something of type myClass. It's going to change name, okay, to be, okay, Tuddy was the last person. So Tuddy, and then it'll print out Tuddy. And this is going to print out console.writeLine obj.name. Okay, so, it's going to have to print out a.name. Sorry. There we go. Cool. I set that up very quickly, but let's just, we've still got some time left, so let's just go through what this is doing step by step. MyClass obj equals new myClass. That's just creating an object of type myClass, okay? And all my classes have this name property. Okay. We say obj.name equals dappe. Cool. So we're just setting the name field to be dappe. Okay. I say, not console.writeLine. I must say function obj.name. Function obj.name. Okay. And I must also say console.writeLine obj.name. Okay. No, don't pass it .name. Sorry guys, I'm being a bit silly. Okay, I must pass it obj. Okay. Sorry about that, just setting up the example. Okay, so I say function obj. So I give it my object, right? I give it my object of type myClass. Okay. In my class, we update name to Tuddy. Okay, and then we say console.writeLine a.name. And when we come back, we say console.writeLine obj.name. So what is this going to print out? What is this going to print out, guys? You tell me quickly. Bearing in mind that all objects are passed by reference, what will this print out? We go console.writeLine a.name, console.writeLine obj.name. You think it's going to print out dappe Tuddy? Tuddy dappe. Woof. We've got basically every possible permutation there. Okay. Guys, remember, what does pass by reference mean? Okay. It's not making a copy. When I give it obj, it doesn't make a copy. No copy. So when I give it obj and I update a.name to Tuddy, no. Okay, so it's working. It prints out Tuddy. Okay. Because this obj is always passed by reference. Okay, when I change it inside function, it also changes obj here. Okay, so that's what passed by reference means. Okay. All objects are passed by reference. Okay. No, I won't apologize. We should still have time maybe. Arrays and collections are also objects. Okay, so let's just see that. Okay, so hopefully we get this. Okay, so this was passed by reference, right? Arrays and collections, they're also objects actually, guys. So what will we say? If I say, I'm going to create a list quickly. Yeah, no. Yeah, Dappe, this is your chance to get it right. Okay, so if I say int, I'm going to create a list of numbers. All right, int numbers equals a list of 1, 2, 3. Okay, we know what that's doing. It's just creating a list, right? A list of numbers. Now our function, instead of taking in my class, it's going to take in something. It's going to take in a list of integers. Okay, int a. I'm going to change a in position 1 to. I'm going to change it to 4. Okay, so it's initially 2, right? I'm going to change it to 4. And here I'm going to print out numbers in position 1. Okay, and here I'll pass it numbers. Okay. Oh, and this must also print out numbers in position 1. Okay. So guys, what do you think this is going to print out? Ooh, it has to print out a in 1. Okay. What is this going to print out, guys? We create a list of integers, 1, 2, 3, bearing in mind that all arrays, okay, all objects are passed by reference, and arrays and collections are objects. What will this print out? Okay. 4, 4, exactly, guys. Okay. We don't make a copy of numbers. Okay. I'll explain these last two. I'll explain those last two next week, maybe, because we don't have the time. But in brief, okay, what did we learn in this last sort of hour? Okay, there are two ways we can pass things to a method in the computer's memory. Okay, to a function. We can pass by value, in which case we make a copy, or we can pass by reference, in which case we just pass the actual memory address. Okay, no. Yes. What? No, come on. It's, again, we'll explore it more maybe next week. It's really not too bad. Don't be hard on yourself. You also missed the first hour of the lesson, right? Tying ties is super annoying. My one friend got super into it though. He always had like ridiculously fancy tie knots. I just stuck to a standard. But that's like, I mean, you just learn how to tie a tie or you don't. Who cares? That too. Yeah, they are useless. Okay. Now you're just being self-defeating, that bear. Come on. Okay. So. Cool. We'll explore this idea a little bit more next week, but hopefully you have a general understanding now. Pass by value means it's copied. Pass by reference means you're passing the actual memory address. Announcer voice over time. Yeah, that's true. But we are pretty much done for this week. I'll finish up memory and events and delegates next week. Okay. Should be okay doing it that way. Thinking of Athena from Overwatch. Okay. Cool. Let me save this code quickly. I guess. Oh, wait. Why did I do that? Okay. Stop sharing. There we go. Let me. How do I open the chat again? It's weird. Ferrari. Polymorphism. Okay. Jeesh. So many chat messages. Oh, I can jump to the bottom. Yeah, cool. Goodbye, everyone. We'll continue next week, finish up with memory, and then go on to events and delegates, which can be quite hectic, but we'll get through it. Cool. Yeah, I'll see you guys next week. You guys happy with Zoom 2 o'clock on Tuesdays? Hopefully you don't have as much trouble setting up next week, that bear. Cool. And I'll make there's not much code here anyway, and we'll probably write a bit of it again next week, so I won't bother saving it to the code wall, but I will upload this to YouTube as well, as usual. Let me just stop recording.